Hello, welcome to Graph Power Hour. This is our live podcast from Senzing. I'm the host, Paco Nathan, and today we are thrilled to be joined my friend and colleague, Christophe Willemsen at GraphAware. And as a Christophe is CTO at GraphAware, and this is the company which produces Hume. And Hume is a graph analytics platform used in mission critical use cases, helping intelligence analysts, for instance, deter complex crimes faster by analyzing, visualizing, interacting with connected data and the analysis of it. Christoph has over 13 years of experience in graph technologies and system design, and he specializes in entity resolution and advanced security patterns for law enforcement and R&D. And I can tell you, working with Christoph, I have been told by other colleagues, uh, Christoph is probably one of the world's top experts in how to make Neo4j work well for your use cases. So he brings a depth of expertise on the system side, but also on the domain side. He's passionate about building solutions that turn complex real world challenges into actionable intelligence. And also, I believe today that Christoph is coming in from home, which is in southern Italy. We were just talking about. He enjoys traveling a lot. I get to travel some and catch up with him in different parts of the world. So with that, welcome, Christoph. Thank you very much.
Thanks for having me, Paco.
Wonderful. Now, I should say to everybody here and people joining, this is live. So as you have questions, please ask them and put them into chat. We'll put them into the Q&A queue. And Christoph, if that works well, we can take some in process while you're talking. We can take some time for answering questions.
Definitely.
And I know you had some slides to go through. How about if we can start in on that, and we may have some questions. I'll definitely have some questions.
Sure. Let's start. All right. So hi everyone. I have a couple of slides, but it will be great. All right. So as Paco mentioned, so we build a product that is to enable intelligence analysts. And when we think about intelligence analysis, we generally think about the corkboard. That actually is human way of representing a graph on the wall, right? So however, that corkboard we see on the screen is kind of small. The reality of our world is that data will look probably more like this for an intelligence analyst, right? So, and what is interesting is that you see that there are some areas in the graph, and this is generally the journey that our customers are taking when starting with graph-based intelligence analysis with our platform. Is they will start probably ingesting their own intelligence management system and case management system. So the information that they have at their own organizational level, right? So it generally will be, offenses, persons, crimes, hypotheses, can be vehicles, typical criminal intelligence domain entities, right? And while this will look, already very useful when visualized as a graph, they want to go further. So there are other sources of data that are useful for intelligence, right? So here the slides are mainly about criminal intelligence, but it can apply to other type of intelligence. So, for example, they can ingest data from custody systems. So why it can be important. For example, if you have a list of suspects and you can connect the data to custody information to determine, okay, if a suspect was actually in custody at the time of a crime, that probably isn't him, for example, right? So very very efficient for those type of analysis because it's connected, right? So Additionally, you can have information for vehicle registration system, typical use case. Okay, you have an incident report mentioning black SUV terminating with a license plate by XY. Well, those are great queries you can do connecting your own data. So once you have vehicles, you might want to add license plate recognition system data. Why it is important? Are there any offender for a particular type of offense that are crossing a state border? For example, if you are actually monitoring entities of interest, you can automatically receive an alert when this happens. So yeah. Or typical use case, convoy detection, like did 3 cars of non-drug offenders were traveling around the same location, around the same time, in the same direction, for a certain distance, etc. Right. So you can have phone forensics data, so typical mobile. When you arrest someone and you have the authorization to extract information from the mobile phone, this why it will generally be interesting to have this type of data. Can be connections to phone numbers, text messages, content, location of the phone around cell towers, for example. That can also be used with vehicle movement data. So you can say, okay, that person was probably in that vehicle at that time. Yeah. And not forgetting, a lot of data can also be created and added to the graph by the analyst himself. Right? So it often happens, for example, you will request data from maybe telephone providers for a particular entity of interest, or you will receive food delivery service receipt, and you want to add it to the graph, for example. Or it can be a photo of the print of a shoe in the mud, right? It can also be added from analysts, right? So, and how that becomes interesting is, of course, everything is connected, but there are additional data that you can extract with traditional, let's say, machine learning capabilities. So, for example, driving license, have a picture, or any other identity document, picture that you can convert to a numerical representation, right? That you can store it as vector in the graph. You can do this similarly for pictures that are taken from phone forensics, right? So they can also be converted to numerical vectors, right? And what happens is that because you can compare similarities, you can have a good understanding what people, if there are pictures that are representing the same person, for example, right? So this can be for connecting data from disparate data set, like here. You can see a phone from one picture from one phone matches the picture of a driving license in another system. It can also be used differently, like especially on a phone. For example, if a person denies that the phone is not his phone, for example, we have seen that a technique to prove that the phone is his is to take all the pictures taken by the front camera of the phone and compare to a picture of him, actually, right? So they will actually, this will be a digital way of having evidence that the phone is actually his phone, right? So, or actually an hypothesis, right? Not everything becomes an evidence. And what does this enable is that often, more than often, like really interesting information is actually scattered across all the systems, right? So you have an analyst analyzing an entity of interest and wanting to have a picture how it can be connected to another entity of interest in the bottom, like at the end of the purple line, right? So and this generally traverses a lot of systems and a lot of connections, right? It is not uncommon to go over 40 or 50 connections to find information that is relevant to a case. Once you have this system built, of course. So now we also need to take into account data that can't be added to the graph. There are a couple of scenarios where data can't be added to the graph. One scenario would be for legal reasons. You will not be able to move the data and add it to another system of records for legal reason, right? So another reason could be that the data is not fit for graphs, right? For example, in the top, we see the license plate recognition. We generally do not recommend, for example, to store every single event of a license plate recognition system. What we have seen is that typically on the span of a week, the same license plates will not have more than 15 or 20 events generally for the same license plate.
Okay, yeah.
Right. So if you can actually minimize like creating windows of space and time that becomes nodes in the graph, it still gives you the information, but for having individual details, you would go to another system if you need the individual events actually. Right. The same could be for financial high volume financial transactions. In general, in the graph, you're interested in the fact that two accounts transacted with each other. You can still maybe do per month, like summarization per month in the graph, but storing like all the transaction details as individual transaction is not always meaningful in the graph. Sometimes it is the only solution, but often we see that it's not the best way. Also, you need to visualize this, right? So you will end up with a lot of noise on the graph visualizations. Right? So, and also, once you have a graph like this, so that's actually a good opportunity also to use graphs for identifying crime patterns, right? So, like graphs are very, very useful. It's so easy to create co-offending networks in a graph, like people that were committing crimes together or around the same offense, and create communities actually of criminals, right? So my colleague Alessandro Negro wrote a 4-series blog post about doing criminal network analysis on the whole graph with LLMs, and so I suggest this as a read. So graph structure are like fit for explainable AI, I would say, right? So because they are very easy to prove and understand. All right, so this is a typical user journey, and we have repeated this for a couple of agencies in the world over the past years. And it's the fact that we work with those customers, we actually anchored some beliefs into how we should do things for graph-based intelligence analysis, right? So, of course, the first belief is that connections matter. There is no surprise that there is graph in the name GraphAware, right? So we believe in graphs a lot. The company was started by graph enthusiasts, really. So all of us were actually in the graph community before joining the company, right? So we also think that conventional approaches have limits. So we can see here, like this is even a simple graph, right, compared to the real world. It can become more complex than that. And what we mean by conventional approaches is not, other tools are legacy, right? It is not especially what we mean, right? It's the way that analysts have to work for finding information that are relevant to their case. So often it is having to do the same thing in multiple different systems without and do this connection manually. So this is very important. It is a loss of time. Some type of crimes and some type of data are actually too complex for other systems. Right? So we have had customer feedback sometimes, like without Hume, they wouldn't even start investigating because the data, when not as a graph, would take them months to be able to find a clue, while by leveraging the graph nature, they can actually start the work faster and actually do the work. Right? So it is speed and precision are critical. It is not okay. We optimize for 1 millisecond query, or it is not. It is okay when if the system becomes a mission critical system, where you have intelligence analysts that are dispatching information they find in the graph to detectives on the field to go to some house and get a warrant and search the house. Precision is critical, right? You cannot the data has to be accurate, and in order to not knock at the wrong door, prevent the wrong person to enter the country, the airport, stuff like this, right? So it is not a joke in the industry where we work, actually, right? So you have to rely on accurate data, data that is connected. It cannot disappear. So this is why we have I personally have some concerns when I hear federated graphs, for example. So if that system disappears or changes without us being notified, and you can't find again the same result, it becomes very complicated. Network visualization is intuitive, of course, for analysts. It is very easy to understand in the beginning. Some graphs are not easy to understand, right? So this is why graph modeling for intelligence analysis matters as well, in order to help analysts making sense of graphs. So it is also not an easy task to make sure that they can use graph, they can consume graph data, like on the screen. And insights must be explainable. This relies on the fact that if you're looking at a graph, it is understandable by the human. So if you have a result of a machine learning algorithm or an LLM, you can trace back to data in the graph. It is not crunching numbers or the results of millions of vectors into some insights that you can't really explain. Right? So everything can be traced back to a path in the graph, for example. Right? And based on our beliefs,
Christophe,
yeah, sure.
I'm curious about one thing. I was just curious about one thing on this point here. Can you give some guidance of what types of, like for instance, if you're looking at a particular criminal network, can you describe like the range of sizes of those networks? Are we talking billions of elements or hundreds of elements, or kind of a ballpark?
Well, criminal networks. So you think that billions would be kind of rare, except if you do this in China, probably.
Right. Right.
So the maximum size of person would generally be the whole country population, right? So probably double, or sometimes because you would have duplicate data often, especially working with different systems. And also, not everybody is an offender. Right? Not everybody. Right. So this reduces the amount of data, like billions. Doing criminal network analysis on billions of data points, I don't think it's realistic. That I don't even think that our customers would have data with a size of 1 billion for these things, right? So, but 55 millions, for example, yes, right? We have seen this, yeah. So yes, this is regarding the size. Right?
Okay, that's really helpful.
Yeah. Great. So based on our beliefs, we have a mission, of course, to support what we say, right? So we're really supportive of graph native technologies down to the metal. So this is why we chose Neo4j. But there are a couple of reasons, right? So is that especially in the industry, we have an enormous amount of requirements regarding security, right? In graphs, right? So we are passionate about graph database. So that means that we can provide a lot of assistance regarding security best practices in the graph, how to model your data for efficiency, how to handle very like massive data sets imported in the graph, what are the best solution, etc. So it's, we did a lot of graph production projects even before starting Hume. So I think it's important that we share our expertise with the community and provide guidance and best practices, right? So our people, are
Fantastic.
in the community, and we have been very influential in the graph community, answering a lot of questions before ChatGPT replaced Stack Overflow. Wrote books about graphs. So yes, so this is our contribution to the community and a passion, right? Right. So
Fantastic.
open integration. So compared to other platforms, you have full access to your data. We don't, we actually let you build the solution that you need to build. So we want you to integrate with not all the systems, but we want you to build what you need to build, right? So it comes with easy user interface for doing data integration from systems to the graph, from the graph to other systems, from the graph to enrich the data, and then back to the graph. So like we have, we support most of the flow that intelligence agencies need to do when it comes to data integration, right? As I mentioned earlier, there is data that is not fit for graphs. Like we spoke about individual financial transaction in pure data, but the data has to be available for the end analyst if he wants to access it, or if it provides like additional insights to what he's seeing on the graph. So we invested a lot of time allowing the connection to other systems, data lakes, Postgres databases, LLMs, whatever is possible in our data integration tool, from a right click on nodes and relationships. So here you can see an example. The user right click on a company node, and we will create a data lake to get the payroll data for a particular company in the last 12 months, for example, right? So that data is best represented as a table, and the user will see it as a table along with his graph, right? But this is on demand. The data doesn't make sense to be in the graph, but is available to the analyst. So, yeah, very, very important. When it comes to graph visualization, we invested a lot of R&D and development in visualization, not for the typical force-directed layout algorithm, right? So the problem with graphs is that the algorithms are, made for, force direction, but it's not always helpful for the analyst. So I will show a couple of things that we either worked on recently or are working on today, and we will be released in February.
Oh, great.
For intelligence analysis. So, for example, we have a customer that is doing cold cases, right? So they actually have information about DNA ancestry, and you can see on the left, like if you would use typical network layouts that you would find in the research, like it looks as a graph, but how it is relevant for an intelligence analysis purpose, right? So we had a lot of feedback from people working on that field, and we actually tune an algorithm for being able to work with this data, right? By having the parents at the right level, the right structure, not having too many edges overlap, etc. Right? So this is we do things for the intelligence analysis, not for graph visualizations, right? So we use graphs, but it has to help the analysts, right? So
is it possible for the customer to iterate on any of those definitions of the layout, like domain specific layout?
Yes, there are options that can be provided. For example, what relationship of interest needs to play a role in the layout computation, for example. So you know, especially the direction, when you work with UBO data, for example, you want to specify direction, what type of relationship, etc. So
Right.
yes, so not everything can be configurable, but yeah, things that are important for the analyst to configure, we try to make it configurable. So other things we worked recently that is already available in the products. This is side-by-side view with graphs and maps. So we have a lot of let's say geospatial data analysis, but that is also graph. For example, electrical grids.
Cool.
So like if you're protecting critical infrastructure, for example, then you can view, okay, what is the impact, for example, or who should I call, for example. So it's and then again you see the graph in the bottom, they are both the same, right? So but before, if you put this data on a map and you have a lot of relationships, well, if you just use the algorithms that are available or the software that is available, this is what you would end up on the left, right? So but this is impossible to visualize for an analyst, right?
Right.
So again, we developed edge collision and fading support
Mm.
for the map view, which makes
Okay.
things way more visualizable, right? So
Oh,
for the
fantastic.
analyst, yeah. And of course, not everything should be visualized like a graph, right? So we had a lot of success earlier last year, actually, with the release of dashboards. So everything is configurable. So from maps to graph widgets to table, HTML, and also all the information you see can come from the graph or for other systems you can connect to, right? So again, we want you to integrate with other things, right? So when it matters. Right? AI, big topic, which is interesting because especially for our industry, it's kind of slow adoption, which is normal. But yeah, so here is just to say that we worked heavily, especially our data science team with our chief scientist, worked heavily in the past on machine learning and graphs and how it can be done in the real world, not on an academic purpose, but really with real world scenarios. So, and again, I recommend those two books from Alessandro, which we know they are here to stay. AI is here to stay. So
I'll second the recommendation very strongly. Also, I agree that Alessandro Negro, chief scientist at GraphAware, has done fantastic talks, articles. These books here, the one on the right is actually very recently updated. Saw some
it
of that.
is just out.
Oh, just out. Okay, great.
Yeah.
Yeah. And it's a fantastic team actually authoring on that. Very good people. But the point being, there's a lot of graph machine learning that you can find out of research and academic, and just look on archive. They may have some code. Good luck getting the code to run. But when you want to talk about using GraphML in actual use cases, real production use cases, especially mission critical like this, Alessandro Negro has been my go-to for like showing how this actually works. So highly recommended.
Yeah. And of course, we on a Senzing sponsored webinar. So what about entity resolution? I cannot miss it. So because this is everywhere mainly. So you saw all those siloed data sets connecting into one uniform graph is a dream. The reality is that there is, they don't have the same IDs. Name of peoples are written differently, even date of birth. So the reality is that you really need entity resolution, right? So I just want to bring one slide, which is actually something I worked on with Senzing. So the resolution is done with Senzing. For ethical reason, I remove the name of the individuals here, even though the data is public. I don't want to mix. So what you're seeing here in the top with the name of people removed is actually people that opened a new company in the UK. So you have the data either every day from company's house, or you can connect to the stream. It is public data. And by doing entity resolution, connecting three data sets here, like it is company's house, open sanctions, and ICIJ, and resolving everything together, we could actually identify that the person that opened the company had previous companies that were sanctioned by OFAC or any other sanction authority, actually. So, and using a graph, you can have this information in seconds in your inbox without even opening our platform. Right? By using alerting, you receive an email that there is new companies formed in the UK that have connections to sanctioned entities from OFAC, from whatever country, actually. So this is revealing about the power of graph entity resolution and engineering by building alerting systems and stuff like this, right? So yeah. Now, what we do about it, so go ahead.
I was going to say, so this is a way then of condensing related nodes, strongly related nodes, condensing them down into a higher level of abstraction.
Yeah. So the groups are representing the same entity, to be honest here. So,
right.
But yeah.
All right.
But you wouldn't have the connection without resolution. Everything would be disconnected. Right? It would be three different subgraphs, which is, you miss the point of your using graphs by not doing entity resolution. Entity resolution really completes the graph, right? To have more insights and do things faster, better. So it's really, but we see entity resolution at every organization. So this is either it is done with Senzing or the tooling. It doesn't matter. The need for entity resolution is 100% there. Right? So regarding integration with Senzing, we have some blueprints about workflows where we can detect, like run Senzing in the background as soon as you modify or add data to the graph, and we ask Senzing to recompute the resolution, and we store the results of the resolution into the graph, right? So an interesting aspect, especially in the intelligence community, is how you can actually store resolved entities in the graph. It is often unlikely that you will be able to merge, even if you say 3% are the same. It is unlikely that you will be able to create only one representation of that person with a combination of all the properties and have a single node, right? So generally, it will be you will have what we call an entity group in the middle. That is the resolution, and you connect every single record from every source of data to that entity group, right? So the reason is that often analysts don't have access to all the source of data, so they wouldn't see, for example, the two nodes on the top, and the information per source can be different. So again, we have a strong requirement for security. So that means that that we ensure that you see only the data you should see. Right? So, and if it's so important, and also you can see the label of the group, the caption in the bottom, John McKinsey. Like this is done at conception level. So it is not done when you store the data in the graph. We actually take you can configure this. So we take the most frequent values for the properties you're interested in, and we create that label in the graph. So if you lose access to one of the source system, that label will actually change because it's on a conception level. It is computed when you visualize the data.
So to add a little bit of context then, in these intelligence use cases or law enforcement use cases, there may be information coming in from a variety of different sources. In the US, the intelligence community has the term sources and methods, which means that you have to be extremely careful about any kind of disclosure that might allow tracing back to where did this information come from, because it might be somebody who's in a covert operation, a double agent, an informant, something like that. and you can't have these people exposed because they might get killed.
Yeah.
And also just people in analyst roles have different levels of, what can they actually see? How far back can they peel these kinds of disclosures? So you may get elements in the graph that some people can see parts of, other people can see more parts of, but you have to be very careful about what could be exposed. This is actually both the benefit and the risk with graphs.
Yes, I mean, I would say not especially a risk, but
Yeah, maybe risky, bad idea, but yeah,
more of a technical
caveat. Yeah,
caveats that you have
yeah,
to add some complexity to how you saw the graph, and because it's not easy to consume, right, this entity group in the middle. Um, but
yeah.
it is the way to ensure like 100% of security regarding what you can access. Um,
Fantastic.
and and yes, so it is, we've seen, even, I mean, I didn't see, but we've seen use case. I didn't see the data. Like, you can have a political person in the graph, right, that is actually monitored by, let's say, a protection team, or but you don't want, even if you have a resolution to other, you don't want people that are not working on the protection team to see that there is a connection to somewhere, right? So, and it is interesting because with the very very first agency that I worked with, one of the leaders there told me there are two concepts, which is the right to see the data, and also the right to know that the data exists, right? So this is why, even if you lose the nodes on the top, should the analyst still know that it might be connected to other source of data, or should we just remove the
Right,
group for that analyst, right? So
right.
so this is
Yeah.
very important. Like, it's the right to see and the right to know that the data exists, right? So
Mm.
so you should, so some agencies don't want to leak even that there might be additional data existing, right? So so yes. And again, I say that it is not easy consuming entity resolved knowledge graphs, right? So it is, here, maybe not readable, but it's just to say that we are working heavily on and identifying issues and working on them. For example, how when you search, maybe you don't want to see two individual records if you have access to all data. Maybe you just want to see one, select one, have both brought to the screen. If you click on an individual record, or if it comes from whatever action you do in the graph, like you have just a single node, right? And then you have to expand to the DT group, and then you have to expand to the same individual in another data set. This is not very an easy journey for the analyst. So this we are working on right now, which we call this computer retrieval. So if there is a entity resolved data for an individual record that is brought to the canvas of the user, then we can automatically bring the entity resolved graph along with that node. So you would see automatically all the instance of that person as a group, as a single group that you can expand.
Right.
But we would do this for you. It would not be the analyst that will have to think, oh yes, maybe if I want to go from A to B, I also need to traverse those entity groups, etc. Right? So we want to help the analyst by bringing this automatically. Then
Oh,
then it's more
fantastic.
visual clues, like having groups that don't look like groups, so same size, same icon as a person, for example. Um, when you have a table action, same thing. How you might see twice the same person, even if they're the same, because we keep the individual records for each source system, for example, stuff like this. So this is just a list of issues that we identified when analysts are consuming entity resolved graph. So, and we're working on them, not all at the same time, but yeah, this is something we invest R&D and development on to make sure that we can help the analyst with graph-based intelligence. Right? So,
Fantastic.
and
I consider
regarding
this to be,
slides,
I mean,
that's it.
Oh, thank you very much, Christophe. What you're showing in the slide previous, though, if you could, uh, I consider this to be one of the most sophisticated integrations of visual interactive work with entity resolved knowledge graphs. Um, it is a difficult topic because, frankly, the adversaries are trying to make it difficult. They're trying to hide behind the edge cases, and there's a lot of edge cases. That's where the value is in doing this, and that's what the graph tooling brings, especially this kind of interactive UI work. Um, and getting it right, or just even having coverage of the different kinds of edge cases is a nuance that is deceptively difficult. So I believe that what you are providing here is, in my view, one of the most advanced and most effective interactive visualizations of that kind of thing. So thank you very much for that.
Well, it's lovely to hear. So.
Well, a few impressions here. I mean, one of the things that you're doing really well here is to take where you do have a wide variety of sources and a lot of different types of classes of entities that are going to be in the graph represented, and just again a lot of potential confusion because there are so many possible connections when you're investigating a case. You're bringing that back down to human scale, and going from, again, 50 million or so elements down to something that's what is most relevant for you in this case right now, and and doing it in a way, most of the graph libraries that I use open source, they do force directed, and you end up with a mess. You've got something here that's actually really usable by people. And when I say human scale, it's not just for an individual. These intelligence teams are almost always collaborations. And so you're really providing a lot of the kind of tooling to make that human scale accessibility for a team, which I think is something that's very rare.
Yes, and it's very interesting. I was recently at a customer, and so we were discussing some issues they have with Hume. It's not the real world is that there are always issues, right? You never have the 100% product. But they were saying, for example, let's say you are visualizing an event class or a node of event class or a node of person class, right? So, but the way they actually, combine those data silos into one uniform graph is that, some data about person is only available in one source system. Some other data about a person class, not an instance, just the concept of a person. Some data, what I mean data is the type of properties that you have. Some other type of properties are only available if the data comes from this system, right? So this is, again, something we are working on as well, but I don't have a mock-ups or slides, but it makes sense, but because the people that are actually using a tool that combines different systems and they used the other systems before or still are using it, right? So we are not trying to replace another system. They are used to know that, okay, if I visualize a person and I want to expand this person from that is coming from this system, don't show me all the properties for every other system, right? So we are, and the same is for the type. The same is for the type of relationships, right? So, like if you have a phone number, right? The phone number extracted from a phone, it can only come from a phone forensics source of data. It cannot come from intelligence management system or stuff like this, right? So, so it is very interesting, and we kind of argue. So, why are you actually keeping those data silos in the graph? Why not actually normalizing? Okay, but I think it becomes hard, and people are used to the system. It's hard to change people as well, right? So this is the most difficult thing in the world, right? It is system people, yeah.
These organizations are struggling with priorities and budgets, and they can't really pay attention to all the transforms in the data that would make sense, but they just probably don't have the bandwidth.
Yes, and also it would be a continuous work to also kind of normalizing and come up with a good name for something that represent multiple different things, right? So
it's an infinite task, as
exactly.
many projects have shown. Well,
Exactly.
I'm curious, what kinds of features then in intelligence, like what are the things that are most popularly requested for analysts to be able to get this kind of immediate insight?
It's a very good question. So I think the most demanded features, and it's not about features in the canvas, whatever, it is self-service. What I mean by that is that our platform, for example, you would need a developer that builds the workflows, that builds the action, what can happen when you right click, like does it has to connect to another system? Those things are developer task, right? At the customer, not us, right? Working with the schema, changing the schema, creating new actions with cipher queries, etc. I think the problem is that the developers generally after 5 p.m. they gone home, but you have a continuous churn of analysts that are working 24/7, right? So what if they need something, they have to wait the next working hours on the next day, and it becomes problematic. So so we worked on some feature in the past, for example. The ability to create alerts based on with our visual query builder, for example. So the analyst doesn't need to know any cipher. He can just create the graph pattern visually and then save it as an alert, and it will run every hour or every 3 hours, or I mean, depending on the time they decide. And then he can receive emails with data that changed or data that is new. Yes, so I think mostly the ability for analysts to work and collaborate without the need for developers most of the time, right? So, it comes with. It's not easy to solve because for doing things efficiently, you kind of need to know, okay, how the data is stored in the graph, what is the correct way to write a cipher query. So you cannot expect this from analysts, right? So we did a lot of optimization with our visual query builder, so that can actually leverage all the information we have about the schema and the database itself to make the queries efficient, for example. Also, if things do not exist in the database, let's say a full text index, like don't let the user do a like query, because it would never return any result. So we would hide it. So we added file, like the ability for analysts to upload files. We are next year we will work on the ability for the analyst to. It's already possible, but we will give more power to the analyst to be able to come with his own file and do really what he wants on the graph. Like with that file, create a graph, publish, make that information available, maybe in the main graph, let's say. So it's, I think self-service and the ability to work without the need of a developer is probably the most demanded features. Then it varies from customer to customer. Some are picky about one use case, some they're happy, but they say, we want more performance. There is no one thing. We did a lot of successful features based on feedback. For example, the dashboard that I showed is very important because they can. It's actually the summarization of maybe 7 or 8 steps that they would have to do in the graph. Now they can just do one click, right? Because every result that you see would be a different action they would have to run in on the visualization, right? So now they can just do one click. The visual query builder, the self-serve alerting. So
it's interesting. One of the things I'm hearing here, a perspective you have, I think it's a nuance that I want to try to elevate because I think it's extremely important. There's a lot of discussion around the tech industry about automation and how can we use agents to just do everything. So I know a number of people not far from me in Silicon Valley who, would just say, hey, we're going to build agents and we're going to find out who the criminals are in your network and then just give you a list. Here's a table. Of course, anybody
Well,
working in intelligence would think that's ridiculous. I think. I don't know.
it is not. Like we did a POC with suspect nomination.
Interesting. Okay.
So yeah, and you can leverage some graph data science algorithm for that as well, and LLMs of course. But yes, we did some work for for the analyst to say, okay, I have this case, suggest me some suspects, right?
Okay.
So
Yeah, that makes sense. That
or
makes sense.
what is the data that I should probably prioritize for investigation, for example, kind of
Interesting.
guide
Okay.
the analyst
Yeah.
by removing maybe some noise information, or suggest him something that is probably most important. Another thing.
Interesting. Oh, very good. Well, I'd like to run something by you though. My impression was, a lot of what you've been describing is maybe less about trying to fully automate the tasks and
Mhm.
more about bringing down the time scale, because it does seem
Exactly.
like in a lot of these
Like
situations, people are deliberately trying to make it more expensive to be caught, or at least indicted,
exactly.
prosecuted.
It is the same for developers. Like
Yeah.
if I can be helped by something that would reduce the boring task
Right.
that do not leverage my skills,
Right.
then it's massive opportunity for AI, for whatever, right? So, but yes, like if the analyst has to do stuff that is not boring, but that is not too
Repetitive or
much
something.
meaningful,
Yeah.
then if it can be automated, it would be um, heavy benefits. Like I remember we heard from a police officer that said, if I can have automatic report generation, I would be the best employee of the month every month. It's,
Right.
so, so,
Well,
yeah,
it is astounding. I mean, for people who work in intelligence, how much you end
yeah,
up having to write reports and
yeah.
just how much your time, it's really not the probably best use of your
Mm.
of your talents. Um, I'm curious too. One of the other criticisms we hear often are around, or again, I'm around San Francisco Bay Area. Um, a lot of AI applications have incredible capabilities, but the real difficulty is actually that last mile of interactive user interface that you can, yes, we have all kinds of tools we can bring in, we can do really smart things. Getting it in front of somebody who understands and can take action is extremely difficult. It seems like really you're providing this like single pane in front of uh, teams of analysts where you can pull together not just the data sources, but also a lot of different kinds of technologies. Like we say, we may be having some work from agents. There may be some RAG involved. There's other types of methods. Maybe I know what you were showing before was getting into multimodal and some
Mm.
embedding cases there. We can kind of connect the dots in the graph because of the embeddings. So it seems like a lot of the superpower here that you have is to bring that interactive UI on top of AI applications. I'm
Yes.
curious about your perspectives on that and what you're hearing.
So we did a lot of UX research regarding AI. So I didn't show, but you can have the side panel and have a chat to chat with
Yeah.
what you want actually. But it's hard. First, I think the first barrier of adoption is the sensitivity of the data, right?
Okay.
So and if you want to, let's say, make it secure 100%, then you have to run on premise, right? So and not it's also the second barrier then is IT, like how to deploy
Right.
LLMs on premise, right? So things that would work, not giving me an answer in 50 minutes, right? So uh,
Right.
so this to us this is the first barrier. So actually, I am myself working on security with LLMs
Okay.
in R&D, and in 6 weeks I have a talk at Note 25 if you want to
Ah,
attend. So
Looking
yeah.
forward to that. We'll put that in the show notes also.
Yes. Then the second is legal, of course. Like the data generated by LLM, what does it become, right? So
Right.
you have to. Our stand is that it has to become a new source of data with a different type of confidence, right? But it has to be visually clear to the end user that data is actually um, coming from a non-human, right? So, and it's not only LLM and things like this. You would have the same with entity resolution, right? So it's
Sure.
very important that that the relationship that says that two persons are the same, like there is enough traceability and confidence and risk assessments regarding, okay, are we actually able to make use of this, right? So
Right.
yes, and regarding the UX, it is I think it is a continuous research. My point is that LLM shouldn't replace something that can be done with a good user interface and without LLM. First thing, right? So then, because it will always be done better without LLM. Most of the case, right?
Right.
So if you can do it without, it will be better. Um, then a lot of context regarding where you are, what are you visualizing, what did you visualize before, what case you're working on. So it's you have to leverage a lot of things. We don't. I don't have a solution. I don't. I think nobody. I mean, nobody in GraphAware has a solution either. But we are. We want to make sure that if we spend a significant amount of time and development into building something, we want to make sure that it's worth it. That means that we need validation before
Hmm.
from the intelligence community that it will be used. And because of there is some slow adoption, I think it's hard to. So I think it takes more time than in you if you work in another industry, right? So
Certainly.
yeah.
Certainly.
So yes, we are actually doing validation. We have customers using LLMs, but everything takes time. We had a lot of good feedback regarding summarization, for example, or identity extraction with LLM, where they said, yes, it takes the text and extract entities, but it doesn't do it as an analyst would think by going through the text. So for
Interesting.
example, we had
Okay.
so we have people that are actually working on with this customer. Okay, then explain how would you think going through this, and then tuning prompts, and then making the LLM behave like an analyst would behave by reading the text and extracting entities and then summarizing the document, etc. So it's a lot of work, to be honest. So
And
yeah.
I mean, you and I have had conversations also. I mean, I know there's research in
Mm,
progress now to try to understand how to provide more of that kind of
mm,
guidance of how does an analyst think and have that structuring what sorts of summaries might be coming out of LLMs.
yeah.
But again, it's research. I mean, this is something, and by virtue of being involved, this being used by the intelligence community, the feedback loops are much slower.
Mm,
It's much more difficult to get that for a lot of good reasons.
yes.
So we're in process right now, and it's exciting how these technologies can be brought in, but it will be a process of time.
Yeah.
I'm curious about one thing. If you could characterize too, just kind of one of my last questions here. Um, working with Cipher, there's so much we can do with Cipher, and also calls out to APOC, etc. But when people are working in Hume, is it mostly Cipher? Or, I mean, are the functions added into Cipher queries? Is there subsequent scripting processing, what's the mix there and relative split when people are
Mm.
developing with Hume?
Yeah. So most of the actions you develop, so things that would be with Cipher with let's say a bit of a sugar syntax into how you can return things. For example, you can
Okay.
say, okay, return this as a virtual relationship, for example, or virtual node, or highlight this node with this ID when the result is returned, for example. But when things becomes complex, I would say you should go through the integration tool. So Actions can just call the integration tool, where you have the full power of connecting to Leo4j, do what you want with Python. In June, we released the first version of the product, which has full native Python support. So you can install libraries that you need to, and then you can just create your, like you would create a Python script. You can do it for an action. But then it's you just read data from Neo, do what you need in Python, or construct your query with Python and run it on Neo. Like the limit is your imagination.
Okay.
Yeah.
Oh, fantastic. When you're doing work with LLMs, are you then calling out through Python typically, or is that a typical kind of avenue?
Well, you could, but it's not the recommended way, because for example, we have all the secrets management, and we have HTTP components that support the secrets management. So you would generally prepare the body that has to be sent to the LLM, and with Python, and pass it to the next component in the UI, which would send this as a HTTP request to the URL that you decide. We're using the right secret that you would never see, that would never be logged, etc., and has a retry mechanism. Like we built a lot we spend a lot of time in engineering, also like automatic retries, support for secrets, so that you can leverage all of the work we've done. If you would just use a Python script, you would have to recreate everything by yourself, so it doesn't make sense.
I see what you're saying. I mean, there's definitely sort of, you can think of like a client-server separation, but there are things that need to be handled more on the back end to be handled properly and also efficiently. Having it all come out of the front end, of course, wouldn't make sense. So,
but it's a message flowing pipelines. So when it comes to the Python components, you have the message like with the data that is flowing. You can do your processing with Python, and then return what should be sent to the next component, right? And that's it.
Okay.
So it's
like a streaming workflow.
Exactly.
Interesting.
Yeah.
Oh, very good. Alrighty. Well, thank you very much, Christophe. I've learned a lot. I really appreciate. We'll have the recording up. I know that there are people in the chat that are saying they had some troubles with video while they're live. We'll have the recording up shortly. The way this platform works, of course, it uploads and gathers from you and I both. That will be going on behind the scenes. We'll get the recording up probably within a couple of weeks or so, but I think that even immediately after our call, there will be a replay. People are going to hit the URLs there. So I want to thank you, and I look forward to seeing you actually in a few weeks.
So, in 2 weeks.
Exactly.
Yeah, exactly. All right.
Wonderful. Thank you,
Paco.
Have a good day.
You too. Thank you.